Hi there! Welcome to the 23rd episode of the Synth project, where we are going to build a synth together. Adapting an old keyboard to the needs of the synthesizer was a task more complicated than I thought. After opening its case and discovering there were no actual switches within it, I had to find a viable solution to reuse the mechanical keys and attach to them real switches. It took me 3 different attempts before I could find a good way to attach the switches and make them consistently operable for generating the control voltages. Here is the story on how I did it. Hopefully this story will give you ideas for your particular case, if you, like me, are in the process of making your own synth. Let's begin! Here is the keyboard I got. It was originally used by the young son of a friend of mine to make his first steps in piano learning. You can see there are still residual labels on each key to identify them. I first spent some time removing all the labels and cleaning the keys for the residual glue. I also had to remove all the electronics inside and all these controls on the panel, since I don't need them anymore. After cleaning the keys, I had to open the back underneath the keyboard to uncover the switches that I hoped were there. Here is the metal plate I found on the back of the keyboard, held in place by a number of screws. The metal plate was positioned right underneath the keys, and so the idea was to remove it to uncover the keys from the bottom side. So I started by removing all the screws, one by one, and the hope was to find switches that I could disconnect from the existing circuitry, which I had to remove anyway, and use them for my own circuitry, similar to the one used for the mini keyboard. But look what I found once the plate was removed. 2 long PCB strips with diodes soldered to them. My guess was that the longer strip dealt with the majority of the keyboard, and it was separated from the lower octave because that part was also used to handle the rhythm section. And of course this was not promising. The diodes were definitely an indication that the keyboard was controlled by a diodes matrix, and the PCB directly underneath the keys made me suspect the worst, that basically there were no mechanical switches, and instead the PCBs themselves integrated some sort of membrane switches, like those used for the calculators. Membrane switches are not good for this application because they do not present a low and consistent resistance when closed, and therefore they may alter the overall value of the resistors in the synth keyboard circuit, causing imprecise notes to be generated. To verify whether I was right or wrong, I removed the shorter PCB strip to see what was hiding behind it. And yes, my fear was confirmed by what I found. Look! Each key pushes directly on the PCB through a membrane that is supposed to make some sort of contact on the PCB itself. I also realized that even though each key has a spring that brings it back to the rest position when not pushed, the mechanical structure of the membrane contributes to keep the keys into the rest position, and so to avoid mechanical issues I decided to leave the PCB alone and put back the piece I just removed. I then realized I had to make my own switches. The first solution I tried came from the Music from Outer Space website. Browsing around, I found an article talking about the possibility of converting a keyboard using reed relays, one per key. The reed relays would sit at a certain distance from the keys, and would switch when a magnet glued to the key would get close to the relay when the key is pushed. In order to glue the magnets on the keys, I had to make sure there was no dirt on them, and so I started by cleaning all the keys with some alcohol and a brush, and then I waited for a few minutes to let everything dry. To glue the magnets to the keys, I used a cyanoacrylate-based glue, supposed to be very strong, and so the magnets would not detach over time. This choice turned out to be a problem, because I almost glued the keys to their support, making them completely useless. Fortunately, I was able to fix that without damaging the mechanics of the keyboard. I also had to wait for a while until the glue started working before moving away the tweezers I was using to hold the magnets. The fact that the tweezers were made of steel didn't work on my favor either, since the magnets kept sticking to them. Anyway, at the end I was able to glue a few magnets on the first few keys. and before going any further, I decided to run a few tests to see if the solution was going to work. For that, I soldered some reed relays on a breadboard and temporarily attached the breadboard above the keys. The reed relays were able to switch when I moved the keys with the magnets, but they didn't seem that reliable. Sometimes they worked and sometimes they didn't, and sometimes after they switched on, they remained on even after releasing the key. So the magnets didn't work properly, and I started thinking that the problem was in the position I put them. Should I have put them flat on the keys instead of a 90 degrees angle? And this thought led me to the second solution. The problem was that I couldn't glue the magnets on the keys in the right orientation because the keys were too thin. To solve the problem, I 3D printed magnet supports for all the keys, like this one you can see in OpenSCAD. The idea was to glue those two little wings to the walls of the keys and use the other side of the support to hold the magnets flat in their own receptacles that were dimensioned in the size of the magnets. The annoying thing was that different type of keys had different width. There was the width for the black keys, the one for the C keys, the one for the D keys, and so forth. Really annoying, and so I had to measure them all and print a number of supports with different widths. At the end I was able to make them all, and I started gluing them on the keys one by one. But again I risked dripping the glue on the key mechanics and stick the keys so that they couldn't move anymore. Very risky. However, I was finally able to glue all the supports with no adverse effects. Really tedious, but I made it. And here are all the supports in place, and you can see how they move up and down when I push and release the keys. Very functional, I believe. But, and there is always a but, gluing the magnets on these supports was another daunting task. To begin with, I used plastic tweezers instead of steel, and that way I eliminated the problem of pulling the magnets when removing the tweezers. I also kept using the cyanoacrylate glue since it works very well on the material of the supports, which is PLA. Now, rather than gluing the magnets one after another, I started gluing them keeping a certain distance from each other. I noticed, in fact, that if I glued two of them very close to each other, without the glue on the first being set, they would move, attracted by each other, and jump one on top of the other. I hoped that waiting for the glue to set on one, gluing the other one close to it would have been easier. Well, it wasn't really so. I even changed the type of glue, using a denser one to help the magnet stay in place. And still, look how that magnet started moving and jump on top of the other that was already set. And every time that happened, I had to go to the rescue, of course. And again, moving and jumping like they were alive. I even tried to keep the keys pressed with the help of some tape to keep the magnet further away from each other, but I didn't solve the effect I hoped for. At the end, I ended up using hot glue, which cooled down right after I put in place the magnets, and so worked just fine. If I only used that since the beginning. But finally I prevailed, and all the magnets were nicely in place. It was then time to try again with the reed relays, for which I used a piece of pegboard and attached it to the back of the keyboard with these sticking pads. And like I did in the first attempt, I had to lay them down in layers to achieve the correct thickness between the magnets and the reed relays. I carefully bent the leads of the reed relays to avoid breaking their glass, and positioned them on the breadboard so that they would be exactly on top of each of the magnets. Then I soldered all of them to make sure they would not move during the experiment. While doing that, I realized that the leads of the reed relays were not easily solderable, and so I used some liquid rosin to help with the process. Finally, I attached the perf board on top of the magnets, and I soldered together the lower end of all the reed relays, like it needs to be done in the final circuit, attaching also a wire for connecting it to the multimeter I used for the test. But when I went to test the reliability of this setup, I found the same issues as in the previous attempt, and that's when I decided to abandon the idea of using reed relays. Well, at least I didn't have to throw away all the work done up to that point, The supports I made still ended up being useful for my third and last solution. Since the use of reed relays didn't result viable for my needs, I made these supports with my 3D printer. They were made to lay above the keys like this, and to glue on each of these wings one of these switches. When a key is pushed, it presses against the switch flap and causes it to operate, therefore establishing the electrical contact I am looking for. With these supports in place, all the switches will be held in position like this, and pressing the corresponding key, the switch will be operated exactly like this. Just for completeness, here is a view of the OpenSCAD design of these supports. Given the limitations in size of my printer, I had to create 3 different holders to cover all the 49 keys. And I also had to provide different distances between the wings to account for the different distances among the keys, as I explained earlier. Note that this was my own solution. Depending on the type of keyboard you will be using, if making your own synth, you may need to resort to a completely different solution. So, although I will put all the CAD files in the user archive, keep in mind that you might not be able to use them, or at least you will probably have to make some modifications. And now here is me gluing the switches on the wings of the supports. You can see how I use it again, I cyanoacrylate glue to start with. Be warned though, that in my case the glue ended up percolating inside some of the switches, making them inoperable. I ended up having to replace about 1/3 of the switches once I realized what happened. To prevent the same problem to happen again, I decided to use instead hot glue, and that worked effortlessly and effectively, and it was much faster to use than the cyanoacrylate. This mistake costed me a whole week between the time to wait for a second order of the switches and the time to remove the damaged ones and replace them with new ones. Here is the first completed section of the switches ready to be mounted on the keyboard. And here are all the 3 sections. Another thing I had to 3D print was this set of 3 bars, which I used to support the hanging side of the switches when installed on the keyboard. You'll see how they are supposed to work once I show you the whole setup. Yes, which is actually right here, and you can see on one side there is the big support with all the switches attached to it, and on this other side there is the bar attached to the keyboard case and glued also to the switches so they stay firmly in place while being pushed with the keys. And now was time for wiring all the switches and assemble the voltage divider for generating the control voltages. Here is the schematic for cabling the keyboard. You can see that each switch is used as a normally open device. One lead of each switch is connected to the corresponding lead of all the other switches. The other lead of each switch is connected to a node of the voltage divider. The voltage divider is connected on one side to ground and on the other side to the current generator on the keyboard controller. The common connection of the switches is the control voltage output. All 3 connections, ground, current generator and CV output, are connected to the keyboard controller through a stereo mini jack. All the connections on the keyboard have to reflect this schematic, regardless of the number of keys. So let's see how I did it. With the components I used, the 2 leads for the normally open switches are those on the top side of each switch. I have used the central lead as the common connection for the CV output, and so I connected with a bare wire all these leads together, basically soldering one end, laying down the wire across all the switches, and then soldering all the other leads to the wire. I left that far end of the wire long enough to reach the position I have chosen for the jack socket. Once the common wire was fully connected, I tested all the switches one by one by connecting a multimeter to the common wire and to the top lead of all the switches one by one, and then acting on the corresponding key of the keyboard I verified that each switch was turning on and off appropriately. I then started connecting all the resistors one by one across all the switches. The resistors, according to the schematic, had all a resistance of 100 ohms and a tolerance of 0.1%. And here are all the connections on the switches after I was done soldering the resistors. Next I made a hole on the cover of the keyboard, positioned the jack socket in it, and used some hot glue to firmly set it in place. The glue was necessary because the thickness of the panel prevented me to use the jack's nut on the other side. Once the glue was set, I soldered the 3 wires from the switches and the resistors in the correct order, according to the keyboard controller schematic. And of course, I insulated the bare common wire with some shrinking tube to avoid short circuits. Another piece of shrinking tube was used to insulate the wire connection with the last resistor in the chain. Lastly, I applied some heat to the shrinking tubes to set them in place. And I used some more hot glue to fix in place the wires. And here is the jack socket as visible from the front of the keyboard. It was now time to bring the keyboard to the synth and to do the final tuning of the keyboard controller to make sure that the control voltage emitted on the keyboard is exactly 1 volt per octave with a precision on the second decimal digit. So I connected the keyboard and the keyboard controller together through a mini jack stereo cable. Then I plugged into the CV output the jack with the bare cables that I used to take measurements, and I connected the multimeter set to volts DC to that jack. Finally, I accessed the twin port inside the controller module and started the tuning procedure in the same way I did for the mini keyboard. The only difference was that once I verified the tuning on the center octave, I also moved to the other octaves to make sure that the result had also tuned. And finally, I made a reading of the voltage at the 2 ends of the whole keyboard to make sure the difference was of 4 volts exactly, since I have exactly 4 octaves. Note that in the whole process I was trying to have the 3rd decimal digit as close to each other as possible, and that guaranteed that the 2nd decimal digit was exactly right. And now it was finally time to test making some noise. And now, to conclude, a final look-up at the whole synth, with all the modules already built, the keyboard, and a softpot or glider. The keyboard project took much longer than I expected and made me spend so much time. Fortunately, I had other videos ready to go, and so I didn't have to delay the channel schedule. However, I am quite pleased on the results, and now I feel I am ready for other modules that will start driving the synth project in new directions. I have so much in my mind and so many things I want to do, and frankly it would be nice to get some help on what to do next. So would you help me with suggestions? Please leave them in the comments so I can start working on them right away. In the meantime, I'll see you in the next episode, and as usual, happy experiments!